So hi, welcome to another episode of Design Spark Ask the Expert. Today we're going to be talking about motor protection, control cabinet builds, and today we're talking to John Burns from Siemens. John, would you like to introduce yourself to us, please?
Sure. Again, thank you for this opportunity to talk with you today. Again, my name's John Burns with Siemens. I'm an application consultant for the Electrical Products Group here at Siemens. I manage a group called the Application Resource Center, and I'm also a target market manager for several target markets here in the U.S. as well.
Great. Okay, so let's get straight into it. So motor systems are obviously at the heart of the manufacturing environment, and downtime is essentially money. But why is it important to rely on the quality of build within cabinet control?
Quality really plays into the equation a lot on the end user. Again, with the downtime, again, if it's poor quality and institutes a failure, you have that time to diagnose the failure. And so the longer that time takes to diagnose, the longer it impacts your downtime. And the poorer quality products a lot of times also don't provide the necessary diagnostics to show which products just failed. And so as you increase the quality of the products, which will reduce inevitably the failure time, it will also reduce your downtime to diagnose what that problem is. So it's kind of a twofold equation for the end users. For the panel builders, using quality components, a lot of times we'll offer consistency across lines. And so as you use different size motor starters, if you're not using quality products, a lot of times they're going to mount differently. The accessories are going to be different. There's going to be a lot of aspects to those starters that will impact over and above just the quality piece of it.
Okay. Can you just maybe expand a little bit on the different types of switching and protection components that you would find within a modern control cabinet?
Sure. Again, for motor starters, we'll provide both the switching and protection function for motor applications. And here's some typical components for those applications. Now, again, every motor starter has 4 distinct functions that it must achieve. The first one being manual disconnect. And so this product here, which we refer to as our motor starter protector, offers that manual disconnect function here with this rotary knob. The second function that a motor starter must contain is short circuit current protection. Now you could do that with fuses, you could do that with a circuit breaker, but by having short circuit protection also in this product, now you're combining multiple functions into one product.
Okay.
The third piece of that, again, for motor applications, is the overload protection. You must be able to protect that motor from excessive current over time to either have too much current on the wires or damage the motor itself. And again, this motor starter protection device offers that function as well. So you have 3 of the required functions all in one device: the disconnect, the short circuit protection, and the overload protection. The fourth piece of the puzzle is the control piece. And that's where it comes into play with, for motor starters, is a contactor that's rated for motor applications. And so these 2 components will make up a motor starter, okay? Now, you could have individual wires to connect these 2 components, but one of the things we do here at Siemens is we offer a mechanical link module that is also the electrical connection for the devices as well, okay? And so with the mechanical link module, it has these little tabs on the bottom that will lock into, say, the protection device, and now be able to also mechanically connect and electrically connect the contactor, okay? And so now, when you have these 2 devices mechanically connected, okay, and electrically connected, it's a much more secure, quality built type design, but it also saves space and wiring time by having that link module in place with the system. Okay. So we've taken the requirements for the motor starter and added some benefits to it based on how you're going to connect them and by combining multiple functions into a single device.
Yeah. So obviously plays with the fact of good mechanical connection, but in terms of reducing the cost of installation, that's really significant, because if you imagine you're doing that on multiple control cabinets, if you're saving on wiring time alone, that's a huge financial saving, surely.
Absolutely. For the panel builders, wiring time is really important. Again, in their business, you'll have a local company that needs these panels, and they'll put those panels out to bid to various local panel shops. If one panel shop has a distinct wiring time advantage over the others based on the technology that they're using, two things are going to be to their benefit. One, again, they're going to reduce a lot of cost out of the build of
Yeah.
their panel, that now they can be more competitive, on their bid. But also, if say the end customer needs, 20 panels, how long is it going to take you to build those 20 panels? If you're now in a competitive bid and you're going to say, okay, my panels are not only 10% cheaper than my competitor, I'm going to also be able to deliver them 30% faster.
Yeah.
That gives that panel shop a distinct advantage to be able to win more business. And now they overall will win more business, on a monthly basis going out their door for their benefits.
Okay. What would you say were some of the key considerations that engineers used to need to bear in mind when selecting the right kind of switch and protection components, for various applications? What would they be looking for?
Again, what's key for a lot of those, the panel builders is the wiring time, the panel space. Do the components meet the national regulations for, say, National Electric Code, or the specific industry that they're going into, say a robotic application or a conveyor application, things like that. Those are really important aspects. Also, as any panel, a lot of times it'll have different size motor starters in that panel. And what kind of consistency across different size motor starters does the manufacturer offer that panel shop? Again,
Right.
consistency also reduces assembly and wiring time for those panel shops. And one of the advantages of with the Siemens design, again, this size starter here is our smallest frame size, but this will go up to, say, a 10 horsepower motor. Our next size up system is now this assembly. This will
Yeah.
go up to a 25 horsepower system, but you can see side by side, they're very similar in size, okay, and structure. Both have that link module that I was talking about, so both will have the ability to save the assembly and wiring time for that system, okay.
Yeah.
One of the things that we also push on the wiring side is, even though in the US the most popular termination is the screw type termination, another termination is also available. It's very popular in Europe, but it's also gaining popularity here in the US, and that's what they refer to as a spring or a cage clamp system. And now the assembly of this, it's much, much quicker than even this assembly.
Yeah.
It's a pop-in type connection that's very, very secure. And with the spring clamp type connection, it's much more secure over time for the end user from a vibration standpoint. Anytime you ship starters or any components to the end user that have screw connections, the first thing that happens when that control cabinet shows up at that end user site is the electrician will come in with a screwdriver and tighten down all of these
All the
screws,
screws. Yeah.
because they all loosened up during shipment.
Yeah.
With the spring clamp connection, you don't have that issue, okay? Also, from a replacement standpoint, they come apart much easier in the field to be able to have a quick replacement. And as you can see with the two sizes here, which are the same two sizes as this lower system here, the 10 horsepower and the 25 horsepower, we've maintained the ability to do the link connection.
Yeah.
And we've maintained the complete sleek appearance of being the same product line.
Yeah. So I can see there in terms of panel space alone between the two different ratings, that you're not really taking any more space than is absolutely necessary. And you're right what you say with the spring termination being popular in Europe. We're seeing quite a lot of people crossing over into spring termination technology, just based alone purely on the mechanical abilities, but also that time saving for installation as well.
Yes, as people give it a shot and look at it, I haven't seen a customer yet that has gone back to a screw connection. Once they've tried that clamp connection, they move forward with it quite quickly. It's just trying to get that person comfortable with that new technology.
Okay. One of the things that obviously for panel builders or panel shops is making sure that they apply the correct standards, for example. So what is it they need to be aware of for motor control and overload protection components?
Well, the main standards here in the U.S. is the National Electric Code, which is NFPA 70. Another one for panel builders for control panel design is UL 508, as well as UL 489 for circuit breakers. So cabinet builders have to be cognizant of what those requirements are, so that when a OSHA inspector comes in and looks at his panel design overall, there's no issues coming in. So that means manufacturers have to be able to provide a quality component that meets those standards. And that's with these components, again, they are all certified for U.S. usage, from a UL standpoint, from a National Electric Code standpoint for our customers. And we have all the supporting documentation as well as the necessary labeling on all of the products, so that we prove to our customers and, more importantly, to the OSHA inspectors that we're complying with those standards.
Okay. And just from the, if we're looking at protection and switching components, what should we be looking for in terms of evaluation for those in the control cabinets? What really should panel builders be looking for?
Again, back to their needs of saving wiring time and saving panel space. I talked earlier about how the link module on this system saves the wiring time and assembly time for this assembly. Okay, but now think about the three-phase power wiring. Say if I had multiples of these starters, and I've got to bring in that three-phase power wiring to the top of each of these individual starters. How can I do that with a cost-effective solution? One of the solutions that we offer to be able to do that, which is very popular in the U.S., is this comb bus bar system. And so you'll have a feeder connection to bring in three-phase power one time, and now you can have different combs for different size starter assemblies that will bus that three-phase power going across. So again, for the panel shop, it offers them a very cost-effective, quick way of wiring multiple starters together. And as you can see, here's two different size starters. Again, the 10 horsepower and the 25 horsepower rated starters sitting side by side. And so we can do that with our starters going across. And this comb bus bar system is rated at 63 amps. So you can see we can do quite a few of the smaller starters side by side with this system.
Okay, so one of the advantages of maybe using a modular system, starter relays and contactors, overload protectors from the same manufacturer, what are some of the advantages of doing that? Because I don't necessarily think a lot of people give that as much time and credence as they should, whereas you can use one modular system from one manufacturer. How does that benefit the panel builder, would you say?
Well, at Siemens, we've put a lot of thought into the modularity design of the product family for our motor starter line, and it shows in a bunch of areas. First off, as I just showed here with the comb bus bar system, that's one way of doing that busing system, which is great for the panel shop. But think about if you've got four starters side by side, all mechanically linked with this bus bar system at the end user, and all of a sudden starter number 3 goes down. To be able to replace that middle starter, you've got a lot of disconnection that has to happen with
Yeah.
three-phase powering to be able to make that repair. And one of the things we've brought into our modular design is additional bus systems, such as this one here. And so again, both size starters, 10 horsepower, 25 horsepower, sitting side by side. But now with this system, I have an easy plug-in module with a backplane providing that three-phase power.
Yeah.
So again, for the panel shop, it's quick assembly and very easy to design in, kind of like a Lego system, to be able to put in modular multiple starters. And this bus system is also rated at the same as the Cone bus bar at 63 amps. So you're not losing anything from the busing capacity going with this system. But for the end user standpoint now, again, say if this starter was to fail, I can pop off this connection piece here and remove this separate starter, and this one can still be under power. And this is all touch safe design, so
Yeah.
you're allowed to do it in your panel space. So
Okay.
again, you have the modularity and the cost effectiveness for the panel shop, but now it's a great benefit for our end users without any loss of deduction for ampacity for replacing failed units in the field.
Okay. So used in the industrial world, then that will reduce downtime significantly, where you don't have to maybe bring the whole process to a stop to actually do something in the panel. You can isolate particular areas and work on those.
Correct. Another feature of this system is the commonality of accessory items. Say if I wanted to add a auxiliary contact block onto our system, okay? Here's the smaller system. If I plug this on to this module and snap it on, okay, works great. This
Yeah.
same accessory now can also be snapped on just as easy on the larger contactor.
Okay.
And not only can I use this same accessory on the 10 horsepower or the 25 horsepower, okay, I can also do it on a 50 horsepower and a 75 horsepower starter that I'll show here a little bit down the conversation. But common accessories across different size motors, okay, will greatly increase, again, the familiarity on the panel shop side to know how to mount them and how to use them, okay? And also having top mounted accessories allows you this nice close side-by-side assembly. And again, I can remove this separate starter and not impact any of the wiring or the assembly of the adjacent starter. So
Okay.
again, from a modular design, we really put a lot of thought into the components for this system.
So that also leads to the kind of then of the common accessory. There's less cost in terms of inventory, uh, the reliability and the quickness of actually getting those accessories integrated. You only have to consider one of the accessories, and it can go across multiple applications. Yeah.
Absolutely. And again, the benefits are both mechanical. You know, they're used to how they mount and how they dismount, and they're used to them electrical. It's the same terminations. So they know the wiring numbers. They know how to do it on a smaller starter. They'll know how to do it on a larger starter. The
Okay.
consistency will reduce time, again, upfront for the panel shop and also at the end user when they're doing a maintenance mode and they're trying to replace things. You know, there's consistency for them as well.
Okay. Could you just maybe just recap a little bit on the Siemens Sirius modular systems, the switching and protection components? What would be the main parts of the family that you could call out, and the benefits of those within the control cabinet as well?
Okay. I touched on a lot, you know, right now until say for the 10 horsepower and say the 25 horsepower size family. Okay. One of the things, and I talked about the accessories, you know, being consistent. Another thing that's consistent for the system is, and I talked about reduced wiring for the three-phase power side. What we can bring into the play now is reduced wiring on the control side. Okay, better flexibility as to, you know, how do I wire it to these contactors to be able to turn them on and off? How many wires does it actually take to activate the control sequence, for a starter? If you look at a traditional starter, okay, hardwired, it's going to take 5 wires per starter. It's going to be 2 wires to turn the coil on and off for this starter, 2 wires to look at the aux contact as feedback to say, hey, the starter is on or off, and then a 5th wire to look at the fault condition. Is it tripped? Is it shut off? 5 wires per starter. And what we've been able to do is implement a communication technology now onto our existing starters. And now by adding this communication module, it's a 3-wire connection for the communication. And now I'm replacing, say for one starter, I'm replacing 3 wires instead of 5. Not that big of a savings, but what you get now is the ability with this communication module is I can actually do 4 starters side by side, and those starters can be both direct starters, reversing starters, or 2-speed starters. And now that bank of 4 starters with communication modules are still fully controlled and monitored with that same 3-wire connection.
Okay.
So now instead of replacing, say, 3 wires to 5, I'm replacing with 4 starters, 20 wires with only 3.
With 3.
Okay, so you get a great reduction in the wiring time for the panel shop on their system. Okay, you're not cutting all the wires, you're not terminating all the wires, you're not labeling all the wires, right? And for the end user, you're going to have just as much control and improved diagnostics off the system than your traditional starter. Part of this functionality of this communication module, it actually has a voltage measuring circuit that can now go in and measure the voltage across phase A and phase B. So not only can you do the same diagnostic signals that I talked about before, you now have added functionality with this solution. And when I talk consistency, excuse me, not only can I add this comm module to the 10 horsepower or the 25 horsepower system, I can still add that communication module to a 50 horse system right on top of that contactor, as well as my larger system, which will go up to 75 horsepower, and I can still control it.
And still control
the
it.
System. So consistency across the line, from a communication standpoint, is also available with this system. Now, this module is a digital-based system. So again, digital on-off signals, digital feedback. But for a lot of customers, a simple request that they have is, how do I get motor current back off of this starter? What's required to do that with your system? And with our system, we have a very cost-effective monitoring relay that supports the same communication scheme as that digital module that I just plugged on, called IO-Link. And now with this monitoring relay here, again, I can directly couple it on the bottom of this contactor. And now not only will I easily get back motor current as max current, but I also can get back the individual currents, phase of symmetry. I can get back a hour meter, number of starts. There's about a dozen analog signals that can be brought in off of this single monitoring relay for this setup. And I have this monitoring relay available not only for the 10 horsepower system, but I have it for the 25 horsepower system, and as shown here, the 50 horsepower system. And if you look at the majority of the motor starters in the panels today, the majority of them are 50 horsepower or below. And our competitors, in order to, a lot of times, to offer that motor current value, they're going to put a similar monitoring relay below here that's going to have an Ethernet port plugged into it. So if you have several starters in your panel, each one of those starters are going to consume an individual IP address.
Absolutely.
And they may not have that many IP addresses available to them. Me personally, I'd rather use those IP addresses on the larger systems, the PLCs, the variable frequency drives, the HMI panels,
Yeah.
not one per motor starter. And
Mm-hmm.
so with our concept, say if you had 25 motors, I could have 25 of these monitoring relays all going back to one IP address for the majority size starters that you have in your system.
Yeah.
We talked about the bus system here on the smaller ones. For the larger frame starters, we have a larger frame busing system that we refer to as our fast bus system,
Yeah.
where we can mount these larger starters on this type of a shoe, and then this shoe will sit on a rack that I have back here of 3 power terminals.
Yeah.
And so for very high ampacity type systems, you can still have your starters, you can still have your communication, and you still have your modularity that if one of these was to fail, it's easy to replace off the system,
Yeah.
even from the high ampacity starters.
Great. A lot of the things that we've talked about today obviously has been aimed at helping the panel builders, the engineer, and the end users. I was just going to finish off maybe by asking about some cutting edge capabilities within the panel systems, but just want to go back to your digital IO link.
Mm-hmm.
Um, I'm more familiar with IO link being used in the world of automation sensors, but it looks like you're bringing IO link into the control cabinet. Is that right?
Absolutely. Siemens not only offers the IO-Link technology out on the machine like a lot of the other manufacturers do in sensors and in masters modules for that application, but the controls product group, which I'm part of, who lives with the motor starter technology, as you can see, we made a decision to use that same open technology inside the control cabinet. And so now we've applied that technology not only on these, say, starters for communication, or with the monitoring relays here with the starters, but I have a whole suite of monitoring relays that are all IO-Link enabled for 3-phase current monitoring, voltage monitoring, speed detection, temperature detection, all have IO-Link connectivity inside the control cabinet. And again, for 2 main benefits. For motor starters, you can really reduce your wiring for multiple starters. And for the analog signals now, it's a much more cost-effective way to get multiple analog signals that are already scaled into a digital format into your control platform at a very cost-effective price. So the panel shops like it because, again, it reduces their wiring and give them another way of satisfying the needs for their end customers at a faster rate. But the end users really like it, again, because of the additional diagnostic and operational data that the monitoring relays and the modularity gives them to reduce their downtime. So really taking, again, an open technology into our product line really offers our customers some really good benefits to reduce their costs.
Okay, great. What I'd like to do is I'm just going to finish off by going back to where we started. So the original question I asked at the beginning was about motor starters, control systems being at the heart of the industrial manufacturing environment, and what is the benefit of having quality product. And through the whole of the conversation that we've had today, I think you have more than answered that for me. And I'd just like to thank you for having a really good discussion with Design Spark about motor starting, protection, control cabinet design. So John, thanks for your time today, and I hope we talk again real soon.
I really appreciated the time today. I thank you for offering us the opportunity to do this. We're really excited about this product line. We really like working with our customers, and we get a lot of positive feedback from our customers. So again, thank you for this opportunity, and looking forward to talking with you some more.
Okay, take care, John.
Have a good day.